Here we have a 1 ounce fine silver dollar coin minted in 2000, and we'll get the camera to focus on this. Maybe. There you go. 1 ounce fine silver. And it's still in the plastic, but we're going to leave it in the plastic. And we're going to see what it reads on the Minelab Explorer 2. I've had this machine about 8 years and made an interesting discovery. This is what you get with the factory presets. Pretty decent sound, but only reading 18, 20, 21, 22 on the conductivity meter. Interesting. Here we have a bicentennial silver dollar. As soon as it focuses, there you go. And we're going to see what this shows up. Here we go, bicentennial clad silver, not clad, yeah, clad silver dollar. Not what you think it would. Or maybe the other one's not. I don't know. Let's try a bicentennial quarter and see what comes up. Here we go. Something's a little bizarre, I would say. Maybe it's normal. I've heard it was normal. Here's a 1964 silver quarter. This is an alloy silver. It is not pure silver like the dollar coin was. So we're going to put this over the coil and see what it does. It's about where you'd expect to see a good solid silver coin at. Not what I'd expect to see in relation to where the silver dollar coin sat, being it's pure silver. Let's see, here we have a 1/2 ounce lead fishing weight. Probably pretty close to what you'd find if you were hunting a Civil War era park or something, when you're looking for your your maxi balls and your bullets that they used back in the day. About the same size, similar shape. It should read pretty similar to what they do, give you some kind of an idea what to look for. The speed over the Minelab is critical. It is not a fast machine. You have to be a little slow with it sometimes. We got conductivity 21, Ferris reading of 7. All in all, not bad. Here we have a 1976, I believe, copper penny. They stopped making these in '82, and now we have zinc pennies, which aren't worth the metal they're made out of. There you go, 78, according to what I see right there. Pretty good shape. Let's see what it reads. That's a piece of copper there. A little bit of Ferris reading. How about a newer dime? 2006 dime. As soon as my focus comes in here. There we go. 2006 dime. Not much different than a copper penny. Wouldn't expect it to be. Here is a 2010. This is the penny that's made with zinc. These things deteriorate real fast in the ground, and they're not the most stable metal. Here we go. So it's showing conductivity of 28 and a Ferris level of 10. There's the zinc for you. Let's see here. We have a 2005 nickel, just a plain nickel. We find some of these now and again. Let's stick it over the coil and see what we get. That's where your nickels are going to sound off at. It's interesting because it's very close to where your gold and various other oddities sound off at. I'm doing this for a request for a buddy of mine. I have two aluminum cans here. One is a crushed up monster can. It's about as flat, it's about as good as I could get it. And here is a Dr. Pepper can. You would think they're both aluminum, they're both going to read the same. Well, let's find out. There's your monster can. Ferrous level of 3, conductivity of 27. It's large. Shows up real good on the Minelab. I got to move it a ways away from the coil to keep it from interfering. All right, here we have our Dr. Pepper can. What do you think about that? Dr. Pepper can shows up about where some of the other quarters and whatnot do. Once again, we're going to look at the 1 ounce fine silver coin, and we're going to see where this goes. This was made in 2000. It's quite a peach, actually. You can see right here on the bottom, it says it's stamped 1 ounce fine silver, $1. It's worth a little more than that now. So here we go. Here's the 1 ounce coin. You see that? Conductivity of 18 and ferrous of 0. And here is the Dr. Pepper can. Ferrous of 1, conductivity of 28. And this is as flat as I could get it, and pretty much as straight down as I could get it. So, while not being perfect, that's factory settings. That's nothing fancy set up on it or anything. That's about where I could get it to, out of the box and turn it on and go. I'm going to pause this for a minute, and when I turn it back on, I'll have the settings I have ran across it. Change how this thing works. It makes things a little easier when you're using your ears. You can't always trust your eyes, as we've seen. So I'll be right back. Okay, I got my settings back. This is a little different than the new kind of technique I've been reading about on the Minelabs that makes them sound a little different on silver than you would think. Even with the same numbers they show on the screen, it's going to sound different to your ears. I hope. So first thing we're going to do is we're going to run this nice pretty 1 ounce coin, fine silver coin. Focus. There we go. I like cameras with autofocus. I hate them too. Anyways, we're going to run this 1 ounce coin over the machine and see what it does. Oh yeah, hear that sound. That is what you want to hear instead of the sound from the previous few minutes where it was a middle of the road tone. You want that silver to really jump. Okay. Bicentennial silver dollar. Once again, we have a really nice sound. Right up there with the silver, just like it's supposed to. Here we go. 1964 silver quarter. We're going to throw this over here and see what it does. It reads real nice, and it comes up pretty good too as far as the sound quality. There's a bicentennial clad quarter. Let's see what we got here. Again, the coins are all showing their numbers, but the sound is different. We changed the sound from being on the conductivity scale to the ferrous scale, and it makes a big difference in how different items show up on this machine. All right, let's use our lead fishing weight here, half-ounce lead weight. Here we go. Kind of hard to determine. The sound's definitely there. What you're hearing is you're hearing that ferrous scale kick in. The higher the ferrous content, the lower the tone's going to be. Here is our 1978 penny. We're going to see what this thing does here. So, sorry about the focus. Not quite as high as the other coins, but you can still tell it's a coin. You got a little of the ferrous sound in there, but it still reads like a coin should. Nice and bright on that sound. Here we go with our 2010 dime, or I should say, what's the date? 2006 dime. Sorry about that. All right, here we go. Pretty good. Once again, the dime and the bicentennial coin, the quarter, is clad and shows up a little differently than your regular silver coins. Here's a zinc penny, and here again is the copper penny. The 2010 zinc penny, you can see where it's showing up on the meter right there. And here's our copper penny. So yeah, there's a difference. Alright, here we go. Here is a 2003 nickel. We have our little nickel here. There we go. Nice focus there. There we go. There's the date, 2003. Newer nickel. And there's your conductivity scale coming up again. Here's our Dr. Pepper can. Smashed up, about as good as we can get it here. Let's see. Ah, what do you know? We have a silver coin and a Dr. Pepper can. Interesting. Now they make different sounds. Here's our Monster Energy drink can. Lower yet. I got one more surprise I'm going to throw at you. Just give me, I'll be right back, and we're going to stick this in there and see what it does. Okay, I'm back. This first one here, there's one person, two people that I know will recognize that. I don't even have to tell you what it is. Oh yeah, what do you know? It's picking the silver out of the copper. Now this is just a piece of float copper, little nugget we picked up a while back, many years ago. And we're going to see what this thing reads. Very interesting. Once things get up to a certain point in conductivity, it starts going back down. I don't know, but something tells me that's a little fishy. I have read in places where Minelab designed the machine to cap out at a certain area so that you would know if you were digging between a coin or a non-coin item, or if you were digging fine pure metal versus clad in alloys. I'm not 100% sure, but I'm going to do one more thing for you. This won't take but a second. I'm going to put the machine back in factory defaults, and the only thing I'm going to do is turn the threshold down and reset the screen size so it shows up at its full size. Nice factory default screen there. And there's the threshold sound. First thing you should always do after a factory reset is press your noise cancel button, let it do its thing, do not move the machine. Keep the coil as close to the ground if you can, especially if you're in mineralized ground. It will make a difference how the machine reads. Big difference, especially if you're around any kind of power lines or radio antennas. Okay. I'm going to leave the threshold where it's at. Alright, here we go, silver coin. All kinds of weird sounds. Automatic sensitivity is on. Let's get rid of that. Alright, we have the sensitivity in the middle at 16, and we have the threshold to where it just barely quit making sound. If you put your ear up to the speaker, I think it's at 9. If you put your ear up to the speaker, you can barely faintly hear it. Not a bad place to be, especially if you're using headphones and wanting to go deep. So here we go. Here's our nice, pretty, shiny little piece of copper nugget here. And you can see it shows up on the far right hand side of the scale, which is the non-ferrous side, but it shows up in the middle on the conductivity. I don't know if that's because of the surface or because it's an actual pure metal. It's a pure copper. Now we're going to try this one again. And you can see it shows up pretty much in the same place as the other copper nugget did with those settings. That is the factory settings out of the box. The other readings you saw with the numbers where you could hear the difference between everything, that was a group of settings I found that I really enjoyed. So anyways, that's what I'm air testing on my Minelab to try to figure out how to learn this thing. This is it's a rather complicated machine, not for the faint of heart. Still up in the air about it. I've had it 8 years, still trying to learn it. Finally. So anyways, thank you very much. Hope you enjoyed the video, and give me suggestions as to where I can find information. Alright, thank you very much. I appreciate it. Enjoy your day. Bye-bye.